Hi everyone, we are Group 7 from Section 31. Today we are going to focus on the topic of finding inverse matrices by using elementary row operation method, which is ERO. Here is our group members. First, we have Gan Wilik as our leader, Yo Zihong, Muhammad Aika bin Amran, and Ahmad Shafiq Aimah bin Muhammad Azneh. By the end of the video, you will be able to know the properties of inverse matrix and use ERO to find the inverse of matrix. We have introduction to inverse matrix. Inverse matrix only exists when the matrix is a square matrix, which is n by n matrix. For example, we have 2 by 2 and 3 by 3 matrix. And the determinant of the matrix is not equal to 0. If the determinant of the matrix is equal to 0, therefore the matrix is not invertible. The inverse of matrices can be found by using two methods. First, we have a join method, and secondly, we have elementary row operation, which is ERO. In this video, we only focus on elementary row operation. An inverse matrix normally denoted as inverse A. When a matrix is multiplied by its inverse matrix, the product of the matrix is identity matrix. The mathematical expression as below. A times inverse A equal to inverse A times A equal to identity matrix. Now we have the properties of inverse matrix. If B is the inverse of A, then B equal to inverse A. Therefore, A times B equal to B times A equal to identity matrix. If both matrices are non-singular matrices, therefore inverse AB equal to inverse B times inverse A. If A is a non-singular matrix, inverse A power of n equal to inverse A power n. If C is a non-zero value, therefore C times A is invertible. Therefore, we have C times A, then inverse, equal to 1 over C times inverse A.
Next, let me explain about the method to find the inverse matrix. So this video is mainly focused on how to use the elementary row operation to find the inverse matrix. Firstly, we write A identity in the form of augmented matrix. Secondly, we perform ERO until we get the new augmented matrix. Therefore, the inverse of A is equal to B. So below we got the example. So the inverse of 3 to 3 matrix A, B, C, D, E, F, G, H, I. After performing the ERO method, we can get the answer, which is the 3 times 3 matrix PQR STU VWX.
Besides, let me explain a little bit about the elementary row operations. There is some notation will be used when applying ERO. Firstly, interchange the I-row with the J-row of the matrix. This process is denoted as Ri interchange with Rj. Secondly, multiply the I-row of the matrix with the scalar k, where k is not equal to 0. This process is denoted as Kri. Thirdly, add the I-row that is multiplied by the scalar k to the J-row, where k is not equal to 0. This process can be denoted as Kri plus Rj. The purpose of this process is to change the elements in the J-row. There is some condition that cannot be used, which is Kri minus Rj, Ri plus Krj, and Ri minus Krj.
In addition, let me explain the step of using ERO to solve the inverse matrix. Firstly, we obtain 1 in the first position on the leading diagonal. Next, we obtain 0 under 1 in the first column. Besides, we obtain 1 in the second position on the leading diagonal. Moreover, we obtain 0 under 1 in the second column. Furthermore, we obtain 1 in the third position on the leading diagonal. Finally, we obtain 0 above all 1. We must make sure the matrix is under row reduced echelon matrices. is the each column that contains a leading one has 0 everywhere else.
Okay, now I'm going to explain how do we find inverse matrix for 2 times 2 matrix using ERO method. So let's have an example. Let's say matrix A equals to 1, 4, 2, 3. So we need to find inverse matrix of A. So in order to use ERO method, we first need to arrange the position. Let's have A an identity. Since we're going to find inverse for 2 times 2 matrix, so the identity will be 2 times 2 also. Okay. The first step is to obtain 1 in the first position of the leading diagonal. But since we already have 1 here, then we proceed to the next step, which is to obtain 0 under 1 in the first column, which is 2. Our goal is to change these 2 into 0. So, let's use row 1, negative 2, R1 plus R2. Okay. Row 1 will still remain the same, which is 1, 4 and 1, 0. But row 2 will be follow this equation. For example, negative 2 R1 plus R2. Negative 2 times by 1 plus R2 plus 2, and we will get 0. Negative 2 times by 4 plus 3, and we will get negative 5. The rest is the same. Okay. So the second step is we need to make this negative 1 into 1. So in order to obtain 1, we can times by 1 over 5 with negative R2. Okay? So row 1 will remain the same, and row 2 will follow this equation, which will make it 0, 1, 2 over 5 and negative 1 over 5. So lastly, we need to change 4 into 0. So let's have negative 4 R2 plus R1. Okay. Same like before, there will be no change in row 2, which is 1, a 0, 1, 2 over 5 and negative 1 over 5. And this time row 1 will follow this equation, which will make it negative, which will make it 1, 0, negative 3 over 5 and 4 over 5. The matrix that we obtain here will be the inverse for matrix A. That is all from me. Thank you.
For the next example, I'll be showing on how to solve an inverse matrix of B for a 3 by 3 matrix. Before we get to solving the matrix, we have to keep in mind that A inverse, when it exists, the matrix is called non-singular matrix. If it does not exist, then it's called a singular matrix. Then AB, inverse of AB, is the same as B inverse times A inverse. Well, if the matrix has an inverse, then the inverse is unique. A square matrix has an inverse if and only if modulus A is not equal to 0. So for the first question, we will have to solve for this B to get into the values of the identity, and the inverse matrix we will get of the inverse matrix will get on this right side. So first we have to find the easiest row and column to solve, and it will be the first column. You can see there's a 1 here, 1 and 1. First, when there's a 1 there, it's the easiest to solve. So we can solve here using negative b1 plus b2 and negative b1 plus B3. So what we'll get here is 1, 0 and 0. So we have gotten 0 for the first column here underneath that 1. Then for the second column, we'll get the first row will be the same and will remain the same. If the only change in row is the second row and the third row, 1, 3 and 3. Then negative 3 plus 4 will get 1. Negative 3 plus 3 will get 0. Negative 3 plus 3 will get 0. And negative 3 plus 4 will get 1. So we're nearly there already. We have to do the same to the identity side. The first row will remain the same. Then we'll use negative 1 to add into 0. It will be negative 1, negative 1 add to 0 again, negative 1. Then 0 will be add to 1, it will be 1. 0 and 0 will be 0. So both this will remain the same. Okay, on to the next. Now we can see that there's a 1 for according to elementary row method or operation method. We can see that when there's a 1 underneath a value of 3 that is or any value that is not 1 or 0, we can use this one to solve for the top. So we can use this one to eliminate this 3 in the first row. What you can do is we can use negative 3 b1 plus negative 3 b2 plus b1. So we'll get 1 here, we'll get 0 here, 3 here, 3b2, 3 times 0 is 0, plus 1, b1, get 0, then 1, get here. The row that will change is only on the first row, as we're trying to eliminate this, so the rest will remain the same. 0, 0, 0, 1. Then we'll have to do the same for the identity side. So we'll get 4, negative 3 and 0. So the rest will be the same. 0, negative 1, 0 and 1. Next step, we'll do for the same thing, just that we change negative 3 b3, which is the row 3 of the ones that is under the numbers, the value of 3, and we'll add the b1. So we get 1, 0 and 0. We get 1, 0, 0, 1, 1, 0, 0 and 0, 0 here. So we already solved the left side and we got an identity on the left side. That means it has an inverse. So the final answer will be 7, negative 3, negative 3, negative 1. Again, the only row that will be changed is the first row. So the first row will be negative 7, negative 3, negative 3. And the rest will be the same as the previous equation, the previous matrix. So we have solved the inverse matrix of B. So B inverse is equivalent to 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0 and 1. So this will be a non-singular matrix. Now on to the next question. We'll solve an matrix, the inverse of matrix A. So how do we do that? Is we'll do the same. We find the easiest column to solve, which will be the one here, because it had this column here, since it has a 1 at the top. So we can use that one to eliminate the 4 and the 7. So we'll get negative 4 b1 plus b2 negative 7 b1 plus b3. This is 2 b2. Then we will get 1. The answer will get 1, 2 and 3. First row did not change. The only row that will be changed is the second row and the third row. So we get 0, negative 3, negative 6, 0, negative 6 and negative 12. Then don't forget to do the same on the identity side. So we get 1 here, 0 here and 0 here. First row will be the same, negative 4, 1, 0, 0, 1. So since we're using the first row to change the rest, so this ones do not change. The only thing that will be changed is the first column. So we get negative 7 here. Now next, what we can do is we can use this negative 3 to eliminate that negative 6. Actually no, actually it's better if you can use these two negative 3 to eliminate the negative 6. So how do we do that? We'll try first. Okay, negative 2 b2 plus b3. So 1, 2 and 3, the first row will remain the same. I'll write the same thing on the other side, 1, 0 and 0. So negative 2 times 0 plus b3 is 2 plus b3 is 0, and here will still be 0 here. Negative 2 times negative 3 is 6. Add into negative 6, we'll get a 0. This will remain the same. The only thing that will change is the row 3. So I'll do this the same, 1 and 0. Negative 3 will be here 0. Negative 2 times negative 6 is 12. 12 minus 12 is 0. So we get a 0 here too. Then the value at the bottom on the right side, we get 1. Then we'll get negative 2. Then we get 1. So here we can see that this third row contains a row of zeros. So what does this mean is when there's a row of 0, the matrix A does not have an inverse. We cannot go on to solve anymore this equation as we won't get a 1 here. It's hard, we won't get a 1 here. So matrix A does not have an inverse, so it's also known as a singular matrix. That's it from me. Thank you for listening. For the next example, I'll be showing.
In conclusion, inverse matrix only exists when the matrix is a non-singular matrix. In this video, we teach you how to use the elementary row operation to solve the inverse matrix. Thank you for watching this video. Don't forget to like, comment, share, and subscribe our YouTube channel.